Hi, I'm Raghavi Selvam. Today I will be presenting my analysis for Real World Analytics Assignment 2, Predicting Wine Quality with Aggregation Models. Understanding the raw data. A sample of 460 rows was taken from the wine dataset. Each wine has five feature variables x1 to x5 and one target variable y, which is quality. We explored the data using histograms and scatter plots. Data distribution insights. Many variables showed skewed distribution. X1 citric acid slight right skew. X2 chlorides heavily right skewed. X3 total sulfur dioxide right skewed. X5 alcohol widespread. Y, which is quality, is ordinal with fewer unique values. Scatter plots input versus quality showed the relationship between x1 to x5 and y, which is quality. Alcohol x5 showed a clearer positive trend with quality. Selector variables for modeling. From the five input variables x1 to x5, we selected the following four for modeling: x1 citric acid, x2 chlorides, x3 sulfur dioxide, x5 alcohol. These were chosen based on clear distribution patterns, that is, after transformation, observable relationship with wine quality, reduced skewness after transformation. X4 pH was excluded due to relatively flat or weak correlation with Y. Transformations applied. X1 square root to reduce right skew, x2 log to handle heavy skew, x3 square root for consistency, x5 log to compress high values, y no transformation applied. Data normalization. All variables normalized using min-max scaling. This scales data between 0 and 1, which helps model treat all variables equally. Here is a formula mentioned in the slide. Aggregation models used: weighted arithmetic mean WAM, weighted power mean WPM with P is equal to zero point 0.5 and P is equal to 2, ordered weighted averaging OWA. These models are used to predict quality based on weighted inputs. Model evaluation metrics. After applying all four aggregation models, we evaluated their performance. Each model produced different levels of error and correlation. These values were obtained by reading the first few lines of each model's stats file. To view in R, here is a formula, that is the R code to read the values. Best model selected. Based on the certain parameter, the best model is selected. WPM2, which has RMSE 0.150, average abs error 0.115, Pearson correlation 0.424, and Spearman correlation 0.413. Which has lowest RMSE, lowest average absolute error, highest Pearson and Spearman correlation. Weight model weights for WPM2. This slide presents the importance weights the WPM P is equal to model assigns to each of your four selected input variables. Variable importance. X5 alcohol is most important, which is strongest weight. X2 chlorides is also important. X3 total sulfur dioxide has no effect. Prediction input. A new wine sample was used to test the prediction model. The input were x1 is equal to zero point 0.8, x2 is equal to 0.63, x3 is equal to 37, x5 is equal to 7.0. These values were first transformed using the same methods as the training data. x1 and x3 square root, x2 and x5 log transformation. After transformation, they were normalized using the min-max method. These processed inputs were used for final prediction using WPM P is equal to 2 model. Prediction result. The predicted quality rounded around 7. This result is reasonable due to high alcohol X5 and moderate chlorides X2. Best conditions for high quality wine. Based on model weights, the best conditions are high alcohol, moderate chlorides, balanced citric acid, and X3 sulfur, which has no role. Model limitations. The model was trained using only a portion of the available data, 460 samples. It assumes the same pattern applies to all wines, which may not always be true. The model's performance depends on the choice of transformations and how well data is normalized. External factors like grape quality, climate, or storage conditions are not included. Ethics and data privacy. The dataset used was publicly available and does not contain any personal or sensitive information. In the real world cases, we must be careful not to misuse prediction tools for unfair decisions. It's important to communicate that the prediction is based on historical data and may not always be 100% accurate. Summary. We cleaned and transformed the wine dataset to make it suitable for prediction. Different aggregation models were used to estimate wine quality. WPM with P is equal to 2 gave the best result with highest accuracy. A new wine sample was tested and the model predicted its quality to be 7. This approach shows how predictive models can assist in evaluating product quality. Thank you for watching my slides. And I hope you understood my presentation. If any doubts, please contact me to my email ID. Thank you.